And now this is the question, and the question is sound wave having following frequencies are audible to human. So frequencies which is audible to human is between the range 20 hertz to 20 kilohertz. Yes or not? Are you getting it? 20 hertz to 20 kilohertz. 20 hertz means 20 cycle per second, and 20 kilohertz means 20,000 cycle per second. So you have the sound which the frequency of sound which is heard is between 20 to 20,000 cycle per second. Above this you cannot hear, below this you cannot hear. Yes, so 5 is below 20, you cannot hear that. 22,000 which is above 20,000, you cannot hear that. 5,500 you can hear that because it's greater than 20 but less than 20,000 cycle per seconds. And D number is 50,000 cycle per second, you cannot hear that. So it is the correct answer is question number C. Okay, next question. Velocity of sound is measured in hydrogen and oxygen gas at given temperature. Temperature is same. At the same temperature the velocity is measured. Then the ratio of their velocities will be, then we have the formula that velocity is gamma RT by m. Since hydrogen and oxygen both are diatomic, both has same gamma, that is 1.4. R is the universal gas constant, so this is constant. Both are placed at the same temperature, mixed at the same temperature. Yes, they are measured at same. Yes, velocity is measured at same temperature, so temperature is also constant. Now velocity is inversely proportional to root under mass. Yes, so velocity of which one first? Hydrogen, then oxygen. The velocity of hydrogen, the ratio of velocity of hydrogen to velocity of oxygen is root under mass of oxygen by mass of hydrogen, and this is your mass of oxygen is 32, mass of hydrogen is 2, which is your 16, and this is comes as 4 is to 1. So option number B is the right answer. Okay, let us move to next question. Look at this question. Okay, look at this. The question is, what must be the minimum distance of reflecting boundary from the source of sound to hear the distinct echo if the velocity of sound is 330 meter per second? The option is 8.25 meter, 16.5 meter, 31 meter and 62 meter. So how can we solve this? So minimum distance to hear the echo, distinct echo means there must not be reverberation. Yes, the reverberation means if the persistence of hearing, suppose the persistence of hearing is 1/10 seconds. Yes, but the when the sound comes into our ear and another sound comes into the ear in less than 1/10 seconds, then we cannot hear the sound clearly. So persistence of hearing, that is the time, minimum time to hear the distinct sound, is 1/10 seconds. Yes or not? So we are taking time as 1/10 seconds because this is the persistence of hearing, okay, the sound clearly. Now to find that what must be the distance, so velocity is 2d by t. Yes or not? For what? For echo, because the distance should travel twice to come to your ear after reflecting from the surface. Okay, so velocity is given to us, that is 330, and this is 2d, and this is 1/10. So on calculating this is 330 into 1/10 by 2 is equal to d. So this 0 is cancelled. 33 by 2 is equal to d, therefore d is equal to 16.5 meter. Are you getting it? That is 16.5 meter, and option number B is the correct answer. Okay. So let us move to next question now. Okay, what is the question there? There is the speed of hydrogen at NTP is 1270 meter per second. So velocity of hydrogen is 1270 meter per second at what? At NTP, normal temperature and pressure. Then the speed in a mixture of hydrogen and oxygen, then speed in a mixture of hydrogen and oxygen in the ratio, what is there? Then speed in a mixture of hydrogen and oxygen in the ratio of 4:1 will. Okay, the question is the velocity of hydrogen is this much. So what will be the velocity of H plus oxygen mixed in the ratio of 4:1? Okay, so when H2 plus O2 is mixed, yes, H2 plus O2 is mixed, and you are said to find the velocity of mixed one. So since both are at normal temperature and pressure, yes, normal temperature and pressure, so what is the velocity? Velocity is gamma RT by m. Since in both cases we are talking about the diatomic gases, so gamma, universal gas constant, and the temperature at which the gas mixed, so all things are similar condition, yes, are in similar condition in both cases. So we are getting that velocity is inversely proportional to what? Root under mass. Are you getting it? Root under mass. So we are trying to find okay, velocity of hydrogen to velocity of mixed one. Okay, you are said to find the velocity of mixed one, but we are given with the velocity of hydrogen is equal to mass of mixed one by mass of hydrogen. Yes, first of all we need to find the mass of mixed one. Okay, so mass mixed is in the by volume, yes or not? Volume. So B1 M1 plus let's say B2 M2 by B1 plus B2. What is B1? Suppose I am taking B1 as 4, then in what ratio? Hydrogen. So what is the weight of hydrogen? 2. What is B2? 1. What is the weight of hydrogen? Oxygen? 32. Okay, divide by B1 plus B2, that is 4 plus 1. So this will come, this is 40 divided by 5, that is 8. Okay, so put here 8 by, this is 2, so this is 4, and this will come 2. So velocity of hydrogen to velocity of mixed one is equal to 2. So velocity of hydrogen is actually 1270 divided by 2 is equal to velocity of mixed one. So 1270 divided by 2 means 635 meter per second is velocity mixed. 635 second. 635 second is the velocity mixed. So option number B is the correct one. Let us move to next question now. The question is here. The question is, a string of length L, mass m, hangs freely from the fixed point. Okay, so let us, this is the string. Okay, let me make it over here. Okay, where I should make it. Okay, this is the string. Okay, this is hanging from the fixed point. The velocity of the transverse wave along the string at a distance x from the free end, x from the fixed end. Okay, this is the fixed end, and from the distance, suppose this is total length is L, this is total length L, and we are going to find the distance of transverse wave x at the distance x from the fixed end. Okay, so what is the velocity given by? Velocity is given by tension by mu. Yes sir, velocity in a string is given by tension by mu, root under tension by mu. So how can we find the tension of this wire? So at this point tension is, so look here, this is the at this point. So what is the mass up to this point? So there is L minus x, yes or not? This is L minus x. So total, in total length the mass is m, in unit length the mass will be m by L, So in L minus x distance, the mass will be m L minus x by L. Yes, this much mass is there. So okay, now velocity is equal to tension is m L minus x by L into g by what is mu? Mu is L by g. Sorry, m by L. This is m by mu is m by L. So m by L and this m by L is cancelled out, and above we are getting L minus x g. We are getting L minus x g. So option number A is the correct answer. Option number A is the correct answer. Are you getting it? Okay. Okay, so we are going to next question, but you can discuss that in what case would we root under this xg. If I say that this is this x is the distance from free end, if I say this x is the distance from free end to that point, then it would be root under xg. But I am saying from the fixed point to here the distance is x, so it will be L minus x into g. Okay, do care that. Okay, next question. A wave propagating in x-axis and y-axis or axis, which axis? Okay, is given by along x-axis. Okay, is given by y equal to a sine omega t minus kx, the equation of wave reflected from the rigid boundary. Okay, when the wave is reflected from the rigid boundary, transverse or mainly in case of transverse, when it is reflected, when it is not mentioned, we have to think that there is the phase change of pi. Okay, when wave is reflected from the rigid boundary, then there will be the phase changes of pi. Yes, so how what will be the change in equation? Okay, so this is suppose y equal to a dash sine omega t. Look at this is minus. Yes, this is minus. When it will reflected, that there will be change in the direction. Yes, suppose this is the wave going, this is the boundary, and from here when it strikes here, the direction will change. Yes or not? Initially it was going in this direction, now it is coming in this direction, so direction changes. So this will be plus kx. Up to this you are clear, I think. Okay, since there is phase change of pi. Okay, phase change of what? Pi from the rigid boundary. I am making it wrong over here. Phase change of pi means nearly in the same level. Okay, so it is phase change of pi. So when there is phase change of pi, then okay, tell me one thing. Sine pi plus theta means what? Minus of sine theta. Yes, because it is in the third quadrant, so minus comes out, and theta is omega, and this is sine omega t plus kx. So it is minus question number. So this is option number B is the correct option. Okay, so now we will be moving to the next question, and the question is, if the pressure amplitude is tripled, what will be the change in the intensity? Okay, I'm doing it right here. Okay, pressure amplitude. What is the pressure amplitude? When we are talking about the pressure wave, then pressure amplitude is, look at this, is minus, pressure is minus b dy by dx, pressure wave. Okay, minus b dy by dx. In case of longitudinal wave, we talk about this. Longitudinal wave is the pressure wave. So this is minus b, and y means what? D. Y means a sine omega t minus kx, omega t minus kx by this is dx. Okay, we are differentiating this one. So this is your minus b, and with respect to x, yes, with respect to s, so this is a is the constant, and this is d sine omega t minus kx, and then the d, when differentiate, what is the argument? We have to use that omega t minus kx into d omega t minus kx by dx. Okay, by dx. So this is minus of ba, and here this is cos omega t minus kx, and this one, this will be this is constant, so this becomes, over here this becomes 0, and this becomes minus of k, yes or not? Minus of k will come out, so this is minus minus plus, so this is bka cos omega t minus kx. Are you getting it? bka omega t minus kx. So this bka is pressure amplitude. This is p0 cos omega t minus kx is the pressure amplitude. Okay, similarly b is this is bulk modulus by density, so b is v square rho. So when you substitute here v square rho, this is b square rho ka cos omega t minus kx. So this is the pressure amplitude. Okay, this is the pressure amplitude. And what is the formula of intensity? Intensity is I equal to 2 pi square f square a square rho v. So when we merge these two formula, we will get that I equal to pressure amplitude whole square by 2 rho v. Pressure amplitude whole square by 2 rho v. Okay, and then we came to know that I is directly proportional to pressure amplitude square. So when pressure amplitude is tripled, when pressure amplitude of the sound is tripled, then what will be the change in the intensity? Intensity will be increased by 9 times, yes or not? From the relation, intensity will be increased by 9 times. Very important question.